I'm Dan Schnabel. I'm here with Austin Bergner, one of our design engineers, and we wanted to talk about the evolution of a standard catalog product and how we've adapted it to various OEM and custom applications. Austin, can you walk us through this application?
This is an application of our HTL drive, which is our high to low drive. It takes in 115 or 230 volts AC and converts it to true 24 or 12 volts DC. This is a cabinet that's designed and built entirely here in South Beloit. It contains two HTL drives, one of which has a battery charger, a PLC, two batteries, and a custom I/O board.
Austin described to you what's in the box. How we got to this point was providing a different approach to the application than what was there previously. We took out a PLC that was here and replaced it in part with a custom I/O board that we provided and designed for them. And in the place of the previous PLC, we were able to put in a battery backup function, which was not there before. And Austin mentioned the custom battery charger circuit. That facilitates a DC backup in the event of a power failure, which will keep the PLC powered and will allow the automation control to continue to operate for up to 24 hours when there's no AC available. So before, two PLCs, no battery. After, half of a PLC, custom I/O, also designed and produced here, and added functionality of a DC backup. So this is one really good example of a custom adaptation of a catalog product, in this case HTL. Those adaptations and that evolution is continuing, and we're going to have Austin describe to us a next generation custom OEM control that uses an HTL as well.
This is another adaptation of the HTL. This control system is very similar to the panel we just mentioned. Behind this mounting plate is a 24 volt DC motor with an integral brake. On this side we have the drive itself with an integral battery charger that charges these batteries here. The drive itself has about 15 I/O, including an encoder input, a 2-channel optical input, 2 Modbus ports, a motion sensor, both wired and wireless, clutch output, brake output, and 10 channels of remote control, 5 of which are wired and 5 of which are wireless.
So Austin described some really nice functionality in a relatively small package, but what was the commercial reason for this to come to be? And what this product brought to this OEM was bring AC power in one side of the cabinet, an output belt on the other side, and in between he's got the custom I/O suite that we developed for him with the motor. Basically 2 or 4 mounting holes. He puts power to it, mounts it, puts a belt on it, and he's ready to go. So it's a complete power pack unit. And as an evolution from the previous control panel that we showed you before, the PLC is now gone. With the I/O capability that Austin described before and the microprocessor capability that we have integral to the drive, we've now made this small enough, compact enough, and economical enough by virtue of eliminating a lot of the componentry that was in the box before. This is another adaptation of HTL technology. In this case, an OEM asked us if we could customize a control for his power drawer application using wall voltage and a very low-cost 12-volt DC motor. We have a mock-up of the application here to show you how it works, and Austin will describe to us how it works.
This is a power-assisted drawer application. The user can either start the drawer operation by either pushing or pulling the drawer from home state. Once it's reached an extended state, the user can simply push the drawer, drive picks it up, pushes it all the way back, drives the drawer out slightly to its home position. Of the components involved in this system are a slide and pulley assembly for the drawer, a small 12 volt DC gear motor, and 12 volt output, 120 or 230 volt AC input HTL. The drive can either operate with or without switches. In this case, the system uses limit switches. You can see one here and there's another one at the front of the slide. The other case, it's based off time and current to control the position of the drawer.
The demo that Austin just showed us is another example of applications where a customer is trying to take advantage of low cost, low voltage DC motors using wall voltage. And there's a wide variety of these types of applications that are developing for us every month. The point I wanted to make here is you're seeing a drawer, but what this really is a linear positioning application. So think of drawers, slides, actuators, any form of linear positioning is something that an HTL is well suited for, and we're going to show you another example of that shortly.
So just to do a quick run through of the components in the system, we use a standard HTL-L, which accepts linear potentiometer feedback. Potentiometer feedback comes from the actuator. The drive itself talks to the touchscreen via Modbus RTU. Talks directly to the HMI. All of the drive is controlled by the touchscreen.
I'm going to show you a couple functions that we've programmed into this unit. This is auto mode. Obviously you could program in a variety of routines depending on what the application is. We also have a manual mode. Imagine a touch screen actuation of a drive-up drawer. And then we've got a settings function. So these are digital functions of potentiometers or other characteristics you may want to adjust on the drive. And obviously with this kind of technology you can do this remotely. If you have a positioning application that doesn't require a tremendous amount of I/O or a tremendous amount of menu commands and variations of menu commands for a drive to perform, microprocessor technology is sophisticated enough now on these drives where we can do a decent subset of the functionality of a PLC on board the drive itself and eliminate that component. We've shown you a variety of adaptations of a standard product. In this case, it was an HTL with an 8-bit microprocessor on board. We've also shown you a specific example where PLC was obviously overkill. With the microprocessors on board, we can displace some PLCs in some applications. And in your case, it may be worth talking to an application engineer and see if we can do that for you as well. I'd like to thank Austin for helping us out with the demos today. We'd be happy to discuss your situation. Feel free to give us a call at 1-800-Minarik, and thank you for your time.